In this section, let's discuss an interesting concept called dearrangement. Say you have a few letters and envelopes. So let's take, for example, 4 letters and 4 envelopes. And if the question says in how many ways can you insert the letters into the envelopes such that all the letters are in the wrong envelope. These type of questions is what we call dearrangement questions. Now, if you had only 2 pairs, that is, you have this pair of letter and envelope and this pair of letter and envelope, you can do this only in one way, right? You can put this letter into this envelope and this letter into this envelope. So if you have 2 pairs, you can do it in one way. Now, if you have n pairs of letters, this can be done in n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial, etc. up to 1 by n factorial. Over here, we alternate between plus and minus signs. Alright, let's keep this aside and let's see in the case of 4 pairs how it turns out. So applying this formula, it would be 4 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. This is equal to 24 into 1 by 2 minus 1 by 6 plus 1 by 24, right? These two get cancelled out. So 24 into 1 by 2 is 12, 24 into 6 is 4 and 24 into 1 by 24 is 1. So this is equal to 12 minus 4 plus 1, which gives me the answer as 9. Alright, so this is the first thing that we discuss over here. We have seen an interesting way to find dearrangement of n items. Now, the second point that we want to learn over here is there is an interesting relationship between dearrangements of different numbers. Now, if you have only one pair, the dearrangements would be 0, right? If you have just one letter and one envelope, there is only one way of inserting the letter into the envelope and that would be right. Therefore, D1 is equal to 0. Now, if you have 2 pairs, D2 we have seen is equal to 1, right? You could put this letter into this envelope and this letter into this envelope. So there are just one way in which you can put the letter into the envelope in the case of 2 pairs such that no letter is in the correct envelope. Alright, what about the case when you have 3 pairs? If you want to find D3, using this formula you can find it, or let's visually find it out. Let A, B and C be the 3 letters and 1, 2, 3 be the 3 envelopes. So one way in which all of them can be posted in the wrong way is put A into 2, B into 3 and C into 1. Another way is put A into 3, B into 1 and C into 2. These are the only 2 possibilities if you have 3 pairs. Therefore, D3 is equal to 2. Now, D4 we have seen over here is equal to 9, right? Alright, now from this pattern, there is an interesting observation that we can make. Dn plus 2 is equal to n plus 1 into dn plus 1 plus dn. That is, for example, let's take an example. D4 will be 3 into D3 plus D2, right? N plus 2 is taken as 4. Therefore, n plus 1 is 3. Dn plus 1 is D3 and dn is D2. What is D3? That's 2, right? And what is D2? That's 1. So 2 plus 1 is 3 and 3 into 3 is equal to 9, which is equal to D4, which is what we've got over here. So this is also an interesting property which is helpful in some questions. So keep it in mind.